Let's take a few minutes and do these examples where I'm going to show you how you can use slope to classify what kind of a quadrilateral you have. So the slope formula you should recognize. The slope is y2 minus y1 over x2 minus x1, and we're just going to use that over and over again. The difference in y's over the difference of x's, the rise over the run. So each of these figures represents a four-sided figure, a quadrilateral. The vertices are A, B, C, and D. And I've gone ahead and graphed them. You don't have to graph them. What I want you to see is if you graph the ordered pairs, you get a figure that looks like a square. What we're going to do is show why it has to be a square, and we're going to show it algebraically. So let's start by calculating the slopes of A, B, and DC, these opposite sides. So the slope of AB, I want to take the difference of the y's over the difference of the x's. And you can go in any order you like as long as you're consistent. So I'm going to start with 0 and subtract 2. Those are the y values. And the x values are 8 and 3. So I will subtract those. That gives me negative 2 over 5. And I'll do the same thing for DC. So again, I'll start with my y values and take their difference, negative 5 minus the negative 3. And the x's are 6 and 1. 6 minus 1. So that's negative 5 plus 3, or negative 2 in the numerator and 5 in the denominator. And what I want you to see is the slopes of AB and CD, they're equal to one another. That means that those sides are parallel. So I've marked them as AB and DC. They're parallel, not congruent. They're parallel. That's what we've shown. Let's see then if the other two sides, the AD and the BC, let's see if those are parallel. So to find the slope of AD, same process. The difference in the y's, negative 3 minus 2. Difference in the x's, 1 minus 3. That's negative 5 over negative 2. So I can cancel my negatives there. I have a positive 5 over 2 for the slope of AD. And for BC, its slope. The difference in the y's, negative 5 minus 0. The difference in the x's, 6 minus 8. That's also negative 5 over negative 2. So for both of those sides, I get a positive 5 over 2. Those sides have equal slopes. That means that these sides, AD and BC, they're also parallel. That tells me I have a parallelogram. So I can check that. It's a parallelogram. So to summarize it, if the slopes of both pairs of opposite sides are equal, that means we have a parallelogram, and you can check it. But what's amazing here is I also can see I have a rectangle without doing any more work. So remember, slopes that are opposite reciprocals indicate perpendicular segments, indicate a right angle. Look, these slopes are opposite in sign, positive and negative, and they've been flipped upside down, 5 over 2, 2 over 5. So negative 2/5 is not just the reciprocal of this, but it's also the opposite of this. Same thing here, negative 2/5, 5 over 2. Same thing here, negative 2/5 and 5 over 2. Negative 2/5 and positive 5 over 2. That tells me at each of these vertices, those segments are perpendicular. That gives me 4 right angles. All of these segments are perpendicular in pairs. So now I have 4 right angles. That gives me a rectangle. So I didn't really have to do any work. I just had to make a comparison to decide if I had a rectangle. If the slopes of all consecutive sides, so the sides that, if you will, are next to one another, that connect to one another, if those have slopes that are opposite reciprocals, we have a rectangle. Well, now we have to decide if we have a rhombus or not. And the trick to dealing with a rhombus is to use one of its properties. Rhombi have diagonals that are perpendicular. So let's check the lengths, not the lengths, let's check the slopes of the diagonals and see if they are opposite reciprocals also. Let's see if they're perpendicular. So this time I want to find the slope of AC. So negative 5 minus 2, that's the difference of my y values. The x's are 6 and 3. So that's negative 7 over positive 3. The slope of my other diagonal goes from D to B. So negative 3 minus 0 will be my numerator. The denominator is 1 minus 8. Well, that gives me negative 3 over negative 7, but that makes positive 3/7. So notice what's happened. These are opposites and reciprocals also. Negative 7/3, positive 3/7. What that tells me is if I draw the diagonals in this figure, I know the diagonals are perpendicular, but that's a rhombus property. So I know this is not just a parallelogram, it's not just a rectangle, it's also a rhombus. So I can check that it's a rhombus. So to summarize, if the slopes of the diagonals are opposite reciprocals, you have a rhombus. So, and then you don't have to do anything more to decide if you have a square. To have a square, you have to have the characteristics of both a rectangle and a rhombus. We checked both of these. That means that we have a square. We're done. It's a parallelogram, a rectangle, a rhombus, and a square. So to decide if you have a square, it has to be both a rectangle and a rhombus. There you go. So let's try another one. That's the full process. So let's decide if the opposite sides have equal slopes. That would tell if we have a parallelogram or not. And then we'll check to see if the consecutive sides are opposite reciprocals. That'll tell me if I have a rectangle or not. We can check the slopes of the diagonals to see if we have a rhombus. And if I've checkmarked both the rectangle and a rhombus, it has to be a square. So let's try. This is labeled example 3. It should be example 2. So I've already drawn it. So here are the ordered pairs for example 2. It sure looks like a rectangle, but that doesn't make it true. Let's actually check to see algebraically that it really is a rectangle. So the slope of the opposite sides, AB, 4 minus 3, difference in the y's. The difference in the x's are negative 2 minus negative 4. So that's a positive 1 over positive 2. So the opposite side is DC, negative 2 minus the negative 3. The x values are 1 minus negative 1. So watch your signs carefully. That gives you positive 1 over 2. So those are equal. So I have one pair of parallel sides. Let's check the other pair. So for BC, negative 2 minus 4, and 1 minus negative 2. That gives me negative 6 over positive 3. On this side, the slope of AD, negative 3 minus 3. Difference in the y's, and the difference in the x's, negative 1 minus negative 4. So that gives me negative 6 over positive 3. So I can see the opposite sides have equal slopes, so that definitely gives me a parallelogram. But notice, if you simplify these fractions, notice what this really is. It's really negative 2 over positive 1. So is this. This is really negative 2 over positive 1. So notice, this is also a rectangle, because the consecutive sides that meet, for instance, here at C, these slopes are opposite reciprocals, negative 2 over 1, positive 1 over 2. Same here, same here, same here. So this meets the characteristics of a rectangle. So we've met the characteristics for a parallelogram and a rectangle. Let's just check for a rhombus. That was pretty clear. This isn't going to be a rhombus, but we can show that's true by calculating the slopes. So for the diagonals, negative 2 minus 3, and 1 minus negative 4. So that gives me negative 5 over positive 5. That reduces to negative 1. So here, negative 3 minus 4, and negative 1 minus negative 2. Most important thing is to be careful with your signs. That's negative 7 over positive 1. So this diagonal from A to C has a slope of -1. The diagonal from B to D has a slope of -7. Those are not opposites, and they are not opposite reciprocals. So what that tells me is we have not met the characteristics for a rhombus. So this figure here can't be a rhombus. But look, if it's not a rhombus, it also can't be a square. So because to be a square, I would have had to have met the conditions for both a rectangle and a rhombus. So I suppose it's possible that you could get a trapezoid. So you would know if you had a trapezoid if only one pair, exactly one pair of the opposite sides were parallel. So maybe these sides were the parallel sides, or maybe just these sides were the parallel sides. That would be a trapezoid. And of course, if none of the sides, if you have no pairs of opposite sides that are parallel, then it can't be a trapezoid, can't be a parallelogram. It's just a quadrilateral, so it would be none of these. So last, try example 4 yourself. Check it with a neighbor. You could also check with the answer key that's posted at the front board, and then you'll be ready to work on the review questions that we marked in your final exam review. See you soon. Bye.